So let's talk about data abstraction now. For the system to be usable, it must retrieve data efficiently. The need for efficiency has led designers to use complex data structures to represent data in the database. Since many database system users are not computer trained, developers hide the complexity from users through several levels of abstraction to simplify users' interaction with the system. For example, there are three levels: physical level, logical level, and the next is view level. So, data abstraction is basically data abstraction makes it possible for the front end application to query data regardless of where the data is stored. These are the three levels of data abstraction. First is the view level, second the logical level, and third is the physical level. Physical level, the lowest level of abstraction, describes how the data are actually stored. The physical level describes complex low-level data structures in detail. Logical level, the next higher level of abstraction, describes what data are stored in the database and what relationships exist among those data. Database administrators, who must decide what information to keep in the database, use the logical level of abstraction. View level: the highest level of abstraction, describes only part of the entire database. The view level of abstraction exists to simplify users' interaction with the system. The system may provide many views for the same database. DMS terminologies: data independence. It is defined as a property of DBMS that helps you to change the database schema at one level of a database system without requiring to change the schema at the next higher level. Data independence helps you to keep data separated from all programs that make use of it. Instance database or database state or snapshot. Database changes over time as information is inserted and deleted. The collection of information stored in the database at a particular moment is called an instance of the database. Schema, the overall design of the database, is called the database schema. So schema is basically the structure or the rough design of the database. DBMS architecture. Types of DBMS architecture. So there are three types of DBMS architecture: one tier architecture, two tier architecture, and three tier architecture. One tier architecture. In one tier architecture, the database is directly available to the user. The user can directly sit on the DBMS and use it. That is the client, server, and the database all present on the same machine. For example, to learn SQL, we set up SQL servers and the database on the local system. So when we install MySQL on our local systems and run any query on the command line, so it is basically a one-tier architecture. Sometimes it may be referred as centralized system with single user system. So that is what it would be, a single user system if you are using MySQL on your local system. Two-tier architecture. The two-tier architecture is similar to a basic client-server model. The application at the client end directly communicates with the database at the server side. APIs like ODBC, JDBC are used for this interaction. JDBC is basically used for Java. The server side is responsible for providing query processing and transaction management functionalities. On the client side, the user interfaces and application programs are run. The application on the client side establishes a connection with the server side in order to communicate with the TBMS. An advantage of this type is that maintenance and understanding are easier, compatible with existing systems. However, this model gives poor performance when there are large number of users. So it won't function well when the service is provided to a very large number of users. three-tier architecture. In this type, there is another layer between the client and the server. The client does not directly communicate with the server. Instead, it interacts with an application server, which further communicates with the database system, and then the query processing and transaction management takes place. This intermediate layer acts as a medium for the exchange of partially processed data between server and client. This type of architecture is used in the case of large web applications. So generally the web applications that we build, we also build a server. We build our own server that makes HTTP requests to uh, to any external services. So at that time, our server acts like the middle layer. So it would be a three-tier architecture. Whereas when you directly make any HTTP request to any endpoint or any external service, so or any external server, so it would be two-tier architecture. Advantages. So the advantages of three-tier architecture are enhanced scalability, due to distributed deployment of application servers. Now, individual connections need not be made between client and server. Data integrity is maintained since there is a middle layer between client and server. Data corruption can be avoided or removed. Security is improved. This type of model prevents direct interaction of the client with the server, thereby reducing access to unauthorized data. So if you have a middle layer, instead of making direct request to any endpoint, if you have your own server, then it would facilitate more security in data integrity, as it would reduce access to unauthorized data. Server system architectures. Server systems can be broadly categorized as transaction servers and data servers. Transaction server systems, also called query server systems, provide an interface to which client can send requests to perform an action, in response to which they execute the action and send back results to the client. Usually, client machine ships transaction to the server system where those transactions are executed and results are shipped back to client that are in charge of displaying the data. Requests may be specified by using SQL or through a specialized application program interface. Server system architecture, so it is a continuation. Data server systems allow clients to interact with the servers by making requests to read or update data in units such as files or pages. For example, file servers provide a file system interface where clients can create, update, read, and delete files. Data servers for database systems offer much more functionalities. They support units of data such as pages, tuples, or objects that are smaller than a file. They provide indexing facilities for data and provide transaction facilities so that the data are never left in an inconsistent state if a client machine or process fails.